So first up, congrats to James. He's been on a roll, and his PowerShell finds were great finds. So I'm Lee Holmes, a developer on the PowerShell team. I've been around since the first version. And what we're going to talk about today is kind of two aspects to PowerShell. So who here uses PowerShell on a regular basis? Nice, that's what I'd like to see. So we're going to talk about two aspects. One is PowerShell operational security, so when you're using PowerShell in a domain enterprise. The second one is PowerShell and scripting security. So if you want to know what awkward feels like, follow up after James on scripting security on PowerShell. So the second bit is scripting security. If you're actually writing PowerShell scripts that might be subject to malicious attacker input. Now, the first thing you... Not it. Good job. So the first thing you probably run into when you start hearing about PowerShell security is researchers bypassing the execution policy. Now, the way to think about this, if you're used to Unix, is coming through the executable bit that you can apply to scripts. Now, you can mark a script as executable. If you don't run it, you get access denied. If you do set it as executable, then it works just fine. PowerShell, the execution policy extends this kind of concept where I can say, maybe I'll let scripts run if they're signed by a publisher that I trust. Or maybe that's only required if they're taken from the internet. So it's a user preference, it's a user choice. We offer commandlets to control the execution policy, and even a command line argument to PowerShell itself that will let you schedule that as your execution policy for the session. So you can see here an example of running through an execution policy. Now sometimes you'll hear a researcher kind of act a bit coy, like they bypassed the execution policy. But in reality what they're doing is, this is a kind of a post-exploitation scenario. They've got full code execution running, and they're just using that command line parameter. So that's kind of just a bit of a digression on that. The next thing you're going to run into is, how do I use PowerShell remoting securely? People talk about PowerShell remoting as lateral movement or whatever else. What can I do as a person who does PowerShell remoting frequently to not let this compromise my enterprise? Now, the way that when you're dealing with, let's pretend you're doing management across 100,000 machines, the chances are that one of them is going to be compromised. Now, this is also true when you're visiting websites and stuff on the internet. And by default, the Kerberos authentication policy basically lets machines know that it's you, trust that it's you, but they can't run code as though it's you. So they can't go off and touch another machine and pretend that they're you. That's the way that PowerShell works. So if you're you talking to a remote host and pretend you want to access some files in a file server, well, by default, that's going to get access denied because that remote host shouldn't be able to act as you. So this is called the double hop problem. Now, when people run into this, they tend to do some bad things like turn on the CRED SSP authentication mechanism. And that gets you to the same scenario that you run into with RDP, remote desktop, where you log into a machine, all your credentials go over there, and it's as though you've interactively logged into that machine. That's a bad idea for large-scale remote management, so we strongly discourage CRED SSP. There's a couple options that you do have. One of those is to, if you really trust specific remoting hosts, you can set up Kerberos constrained delegation. That used to be just a bad word, really complicated, requires domain admin. But that's expanded and simplified a lot more in Windows Server 2012. So you can set it up so that this remoting host can impersonate you onto your file share, for example. Another option is, rather than have the file share be ACLed to the users connecting, so the Lee Holmes account, rather than trust that, you can have the remote share trust the computers that you trust. So if I'm connecting to a remote server, then I can say, well, all access from this remote server is trusted by the file share. That's another way to do it. And then the third situation is, you can always use your credentials explicitly when you need to access a resource. Now, you're making a remoting connection into the remote host. You can still use the netuse commandlet with credentials. You can still use the new PS drive commandlet with credentials. Those will then authenticate the connection between the remoting host and the file server. You do need to worry at that point about the machine being compromised and somebody intercepting the credentials in those APIs, but it's more secure than connecting, entirely with your credentials. So there's a couple of different ways that you can access that. The other thing that people run into when it comes to operational security is treating scripts differently than they treat executables. So they think, I don't need to worry about scripts, but I do need to worry about exes. Now, scripts are just as powerful as exes. As James showed, you can load arbitrary assemblies, arbitrary code. Here's an example. On the left is a C++ program enumerating some desktop settings. On the right, you've got somebody doing essentially the same thing with PowerShell using its add type command. Now, one thing we frequently hear is, hey, how do I make sure that the PowerShell in my systems is more secure? You don't hear them saying, how do I make sure that the C++ in my systems is more secure, which shows that they're kind of, hearing some interesting new research coming out, but not necessarily thinking holistically. So if you're locking down a machine, first thing you want to do is make sure that attackers aren't running random exes on your system. In that case, you pull out AppLocker or some other system lockdown mechanism. You also lock down scripts. AppLocker also lets you say, well, VB script, JScript can't run. You can also tell it to lock down PowerShell scripts based on signatures and everything else. But then you still have some other hosts that can run dynamic code. So as we were talking about before, well, maybe you can run an Excel macro that's running arbitrary code from arbitrary DLLs. Or maybe you're running an HTA or a local web page that has more permission than remote web pages do. So those things aren't handled by AppLocker. So you might come into this pretend scenario now where I've got some amazing host-based intrusion detection on my system that's schlepping off all files, and I'm analyzing those to make sure that they're not malicious and whatever else. You've got this amazing scenario set up. You're now at the 99%, like the absolute top in operational security in the world. And this is where you start to get into the kind of elegance and power thing that we talked about in an earlier presentation, where people are starting to play with PowerShell because it's elegant as well. So you've got this system that is monitoring every read and write to disk, capturing every file, HTA, VB script, whatever else. And now you've got guys up there saying some really good research, like, here's how I can use PowerShell in a forensically clean manner. I can run an attack that never touches disk. This is the kind of thing that we're hearing, and people are getting nervous about it, yet they still don't have a whitelisted AppLocker policy, for example. Now, a way around that, there's two ways. On the system, you can set up a system-wide transcript. PowerShell offers the start transcript commandlet. You set this up in the system-wide profile, and then all commands and their output is automatically logged to a system-wide file. So there's the first thing that you can set up. And the second thing is, through either registry changes or a group policy, you can set up a module logging group policy. I'm not going to get into it directly, but you can see a little bit there in the text where I ran the add type commandlet. The module loading group policy automatically logged that I ran this commandlet and actually what the values of the parameters were. Now, if you're deploying these two things when you're kind of working on restricting PowerShell some more, what you definitely want to be careful about are attacks against the mitigations themselves. So if somebody is changing your system-wide profile to disable logging, then you've got an issue. If somebody is changing your group policies that were doing this logging, then you've got an issue. But you've got this super amazing auditing system that's logging all registry and file modifications, so you're good anyways. So there's operational security in a quick blow through. As you might notice, this afternoon is the fire hose version. Now the language, this is where you're writing a service, and this service is depending on PowerShell scripts for their user interface, or they're doing this in a trusted subsystem model. Now, what are the things that people run into this? And if you're doing penetration testing, this stuff is a gold mine. If you're developing this stuff, pay close attention. Now we get people asking us, how do we encrypt or obfuscate PowerShell scripts? There's a tool that does it. It looks great. I can't read it. But the problem is most obfuscation tools, what they really do, they take the string of your script, send them through this blender that they have a hard time understanding, But ultimately, when you run it, they reverse that process and send this string to PowerShell itself. So the answer is don't do this. Here's an example, just a simple breakpoint in the application that shows the unencrypted script as it's about to get sent to the PowerShell engine. And so most encryption that you see online is of this variety. There's one example where it actually does work out okay, where people use an encryption key and use real actual strong encryption to encrypt your string content. And then when you're about to run the script, it asks you for your password. And then if that doesn't match the encryption key, and not done as a string comparison, that's dumb, but if it's done as an actual decryption key, then that's a secure way to do this. But it's technically possible. I haven't seen it be useful in practice. Now, the other thing to think about, dynamic languages, JavaScript, SQL, PowerShell, anytime you're running system commands in C, C++, C#, anything, all run into this issue of script injection. Now, PowerShell can be abused to get script injection, but there are ways to avoid it, and I'll show you how. Now, the first line, everybody is used to PowerShell as a scripting language. It runs commands. I don't need to be typing in any special commands to run commands. I just run the damn things. But people, when they start to say, well, let's say I don't know the file name that I need to pass to the getACL commandlet. That came from the user. Well, they're not used to how to do that, so they fall back, well, in C or C++, they used to run this system command with some string concatenation, and that worked. Then they find the PowerShell equivalent, and they think that they found invoke expression. But what that means is invoke this arbitrary chunk of PowerShell script. Now you see where this might lay. Now lines 3 and 4, there's an example of how you do it. You just pass that file name as a parameter to the getACL commandlet. If you dump it into a string, you're in problems. Because line 6 shows, well, what happens if that file name includes a statement set terminator in PowerShell, the semicolon character. Now, I just passed in getACL cfile.txt, and then as my next statement, I want to format your hard drive or exfil data, or in this case, just write a warning. Now, if you run invoke expression on that, you're in trouble. So don't be using invoke expression. Script block create is another example of creating active PowerShell script out of user-supplied strings, also usually a bad idea. There are ways to do it, very securely and even more powerful than most languages offer. Now, you've got the first line, getACL path file.txt. This is a commandlet I know, a parameter I know, and a parameter value I know. If I don't know the parameter value beforehand, I can just stick it into a variable and use that variable name instead as the parameter value. So this is like the place where most people make the mistakes. But sometimes you don't actually know the parameters. And this is where I feel bad for people who make this mistake, because they're like, I don't know if I want to use getACL with -path or -literal path. They might have a couple different parameters. So PowerShell offers a feature called splatting, which you take a hash table. You can define it either statically, like I did right here, but also PowerShell hash tables let you just add stuff dynamically to them, and then use that @ before the variable name, and then that whole hash table gets jammed in to the getACL commandlet as the parameter names and parameter values. Now, if you're in some twilight zone where you don't actually know the command name beforehand, you can use PowerShell's invocation operator. So that's the ampersand right there. You can pass in the command name as a variable, and also either pass in the parameters explicitly or use splatting to get through those. So there's an example, like 3 really, really built-in ways in PowerShell to avoid script injection. And if you're doing invoke expression, don't do this instead. Now you might be telling me, but you know what, I got this crazy scenario, I've really got to make this happen. Now the way to do it is to enclose the user's input in a single quote, and then escape all single quotes in that user's input. It sounds secure. That's actually the right way to do it. But at this point, your hackles should be up. You should be having people screaming on your shoulders if you're getting into this point. Because PowerShell language, that's why. What is the most common way that PowerShell scripts are shared? It's not GitHub. It's not TechNet. It's blogs, Outlook. People share stuff all the time. Hey, how do I do this? Oh, here, buddy. Now, what happens when you type a single quote in an email? Well, you get a nice fancy quote. So PowerShell needs to handle all the nice fancy single quotes. Now, if you just escaped the ASCII single quoted string, you're in trouble because the attacker can specify any of the other 4 fancy single quotes and escape out. So if you need to do it, know that you're doing the wrong thing, but this is the thing to be aware of. Now, you might also write PowerShell scripts and be really concerned about sensitive data sitting on a file share somewhere. So you're worried about the attacker getting access to your source code repository, or maybe you've got management scripts that are sitting around in a file share that might have credentials or passwords. Now, the way this is handled in Windows is called the Data Protection API. Now, the Data Protection API says, you give me a secret, I'll give you back an encrypted blob. Now, this encrypted blob can only be decrypted by you on that current machine. So I'm comfortable putting this on a scratch share where anybody can read it because they're not me on my machine. They will not be able to decrypt it. That's strong crypto doing good stuff. Now, PowerShell exposes these concepts through a couple different commandlets. Secure strings are a .NET and PowerShell concept that lets you hold sensitive data. Now, PowerShell has commandlets to read secure strings. You could use them as parameters and everything else. So you can use the import and export CLI.XML commandlets. And these are PowerShell's persistence mechanisms. They persist full-on objects. Serialized forms, the same way that we use in PowerShell remoting. Now, if you put a secure string through these commandlets, PowerShell will actually automatically use the Data Protection API so that the file on disk is locked down to you on that machine. Now, a special case of these secure strings are credentials. They're another very common source of sensitive data. You pass a credential into the import and export CLI.XML commandlets, and you also get a securely persisted credential on disk. Now, one issue you might run into when doing this is, well, what if I need to share this sensitive data between different users or between different machines? The Data Protection API isn't going to help you there. Now, for that, you're getting into a risky area. So the convert to and convert from secure string commandlets, they do let you specify an encryption key. So now I want to encrypt this data with the following actual encryption key. I would not recommend the random key used in line 19. You'll find that is great for data loss, but nothing else. So this does let you specify an encryption key, but then you start worrying about the Achilles heel of crypto, which is key management. If this is all written in the same script, $key equals da-da-da-da, export secure string dash key da-da-da-da, it's no longer encrypted. They just look at that same script that you're trying to protect. So you need to be inventive on how you're going to keep your key separate from the script that you're trying to protect it when it's on a resource. So it was massive blow through. This is that time of the day. The deck, when it's shared, will have a lot of speaker notes that you can read through more slowly. Here are some resources, and we have some time for questions.
Questions for Lee? There's one in the back.
Yeah, we're looking to perform transcripts on all PowerShell activities in our environments and all that. And so I understand being able to apply a global, start transcript. What prevents them from just simply saying like stop transcript and then moving on?
Because you have amazing logging. So you could monitor your logs. If you've got module logging set up, you'll have event logs that show that they ran stop transcript. If they're tampering with the profile, you have this, you can add auditing to those files as well to show when somebody's tampering with the file itself. So there's nothing going to stop them from terminating the transcript and then going crazy, but you'll at least know that they left a mark and they're no longer forensically clean.
Okay. Yeah.
Kind of a question around those same lines.
I don't know where I'm looking.
Over here. Up here.
All right.
Right down from where he was. why don't we have any of that logging on by default? For example, in some of our other products like Exchange, the Exchange PowerShell automatically logs anything by default that makes a change to configuration. So why wouldn't we do that elsewhere?
That becomes an operational question. Exchange has said, hey, in Exchange shell, and they're using the same policy, the module logging, so they turn this on for all of their commands. Then it's an open question of which systems you want this to be logged verbosely on. It's more noisy. If you're running a lot of automation, it might be logging a lot of stuff. So we don't want to log that by default.
I think we're good.
All right, thank you.
Thank you so much.